completing the square with an a term. What's going to happen here is I just have an a term and a number here. It's going to make it a little different. We'll add the c term here in a little bit. We want to start with the beginning. When I complete the square here, the first thing I have to do is divide everything by what is in this a. But I really can't divide and get rid of it because I need to keep it for my answer. So I factor it out. And notice whatever this number is here, I factor it out, even if that means these others have to become fractions. I factor whatever is in front of the x squared in front of all the parentheses. So I have this 2 times x squared plus 10x because 2 times 10x would be 20x. And now I just go about my regular business. I take this 10 right here and I divide it by 2 and I get a 5, and I'm still going to square the 5, but here's what's different. When I put a 25 in here, I didn't add 25, I added 2 times 25, so I need to add 2 times 25 to the other side also, because it was not a 25 but a 2 times 25, which meant I really added a 50 over here. Now here's what's really cool. I have this 2 still in front. This x squared plus 10 plus 25 is a perfect square with that number right there. That 5 that I got right there is the perfect square. I've still made that, and now I just got to minus the 50 from each side, and I am back in vertex form. There, we're completing the square with an a term. Well, let's try an a term maybe a little different, because let's try 3. There's a 3 in front of this x squared, so I factor 3 out of everything. Basically, I divide by 3, but instead of dividing it, I'm running it here in front as a factor. So 3 times x squared is 3x squared, and 3 times 22x would be 66x. Do what we did before. Go over here to this number right now, the 22, divide it by 2, which is 11, and then you're going to square the 11, which is 121. So when I add the 121 here, it's not just 121, it's 3 times 121, which I need to add to both sides. Okay, because I'm doing it 3 times, not just 1. And so then therefore 3 times 121 is 363. And what I love about these here, whatever number I got up here, that 11, that's the number that goes in the parentheses, because I did that on purpose to make it a perfect square. The 11 always doubles to make this one. The number always doubles to make that one and multiplies by itself to make this one. And I have this 3 in front, and then just minus the 363 from each side to put it in vertex form. And there we go. Like that. Let's try ooh. A negative. Doesn't really make much difference. What's in front of x squared? A negative 2. So factor a negative 2 out. So negative 2 out makes it a positive x squared. You always want positive x squareds here, so it's okay to have a negative in front. And negative 2 times negative 20x would be a 40x. Once again, go to this middle term, divide it by 2, which is negative 10, which I'm going to square. Now remember, negative 10 times negative 10 is positive 100, right? Which when I put in my parentheses, I'm not adding 100. I'm really taking negative 2 times 100, which is a minus 200. And then remember this number here, factors to make that negative 10, the x minus 10 in parentheses squared, still with the negative 2. And then I'm just going to move the negative 200 to the other side, which would be adding 200. And there it is in vertex form. Ooh, thank you.